Hello, my name is John Maxwell, and this is a review of last night's class for AP Computer Science in the Arupe Virtual Learning Institute. So, what we have here is a little mistake that creeped in here. It's an S, but what we want to introduce you to is the idea of a class. Okay, this week we have two assignments, one on Easter Sunday and the other fuel efficiency. I'm working in the Eclipse setup. I've sent an email on how to get Eclipse installed and how to create a project. So hopefully we'll look at that email, and if you don't have a compiler on your computer, that you would add them. And I can see already there's a little error here, and I can actually see what it is. It looks like a missing brace here. Nope, isn't really. Well, anyways, on line 2 we see the essential ingredient for any Java program. It usually always begins with a public class statement, and in our case we call this capital T test. By convention, classes are capitalized. Not necessarily required, but most people do. You'll also notice up in this area that we have a file name test.java. All Java files carry the extension .java, so it's just a little heads up, just like Word documents are doc or docx or PDFs are .pdf. We have the .java extension for this class. And basically, I can see what's been removed here. I'm just going to type it back in. It's not as we left it. Okay, very well. Likewise, we have a standard signature public static void main with string square brace args within parentheses. As I mentioned before in class, this is the starting point to a Java software system, or in this case, just a file. It's not a system. But the compiler, or the thing that will run this program, is going to look for the main method. We call them methods. Function is used in other languages, but we call them methods here. And the compiler look for the main method in order to start its work. On 5 and 6 and 7, we have ordinary declarations of integer and double types. You'll recall an integer is a whole number and a double is a real number with a decimal point. Now, there's an added complexity that you don't necessarily have to understand, but here we call something called atom and send in x and y. And these are known as parameters, x and y. And you'll see on line 13 a method called atom, which takes in two integers and returns the addition of the two numbers. And that return type is specified here as an int. So it couldn't return anything but an int, and it gets returned to the print statement for output. We also have another method called atom, but it differentiates or by the number and order or type of parameter. And this is said to be overloaded method, formal term, overloaded. And it takes in two ints and a double and returns the sum of those numbers. Back to line 9, which is up here. Now, right now, we're not asking you to write a program with multiple methods, such as the two atom methods here. However, most Java programs will have more than a main method. The main method, as mentioned in class, will be the springboard to the operation of the program, but it may call on different methods in order to perform a subset of its work. So, really, one of the respondents last night in class mentioned, why have methods? And the answer is we have methods because they are able to break down the work into subunits. And if in a point where you need to alter the program in one particular area to perform a different behavior, you might be able to go right to the method and change it without having to parse through the entire main method, finding the parts that you want to change. The introduction of methods has been something that has begun in, like, way back in programming times, the 50s and the 60s. Kind of parallels organizational development. As organizations grew, they created different departments: purchasing, sales, marketing, all in different units that specialized in different parts of the organizational efforts. So this decomposition into methods is sort of a natural run that finds its parallel parts in nature and in organization. The digestive system, the circulatory system. Why not have different methods performing different parts? You'll also notice that this one has a void, which means it returns nothing. This one has an int, which means it should return an int with a return statement. And this one has a double and has a return of a double. So this is a preview of methods. We'll deal with them a little more. I don't expect any methods to come out of this week's assignments, but I'm not holding you back. We also discussed a variable type called string, and I don't want you to focus in on the screen at this point. What I want you to do is think. We know about the number types int and double. We know about the type that contains a true and false, which is a Boolean. And now we know about the parts that have alphabetic characters. And those would be a string. Now, they're a little bit different than a primitive data type. They're not inbuilt to the language. And so you can see me declaring a string this way: string name equal new string John. And then I can reassign it to Frank in line 9. And it creates actually a new string when I do that. A new object in memory called string, or called name. Name. So line 9 actually is kind of a way to go. And then we can reassign it again in line 10 by using a scanner, which we've imported up here and created up here to allow the user to input a name. And instead of next int and next double, we just use .next. Well, we continue on with our idea of string and create a first name called Roger and a last name called Rabbit. And Roger Rabbit is the name of an animated cartoon character. And then we use the plus signs, which are known as concatenation, to join first name and last name with a space in between and storing it in the string full. We output it, and there we have the basics. Now, one thing to know about string, really the first step about string, besides the fact that they contain alphanumeric characters, things that you don't necessarily compute with in a arithmetic type of way, is that it's a collection of characters with each character in a specific index position. So I've kind of spelled this out. The indexing begins at 0, and the R is stored in index position 0. And the O is stored in index position 1 and the G in index position 2. And you can see this as it's written out here. And the last index position is 11. However, there are 12 characters, recall, and that the 12 characters are stored in index positions 0 through 11. So, like to re-summarize that, a string is a collection of alphanumeric characters stored in an indexed collection. And we're going to use this indexing all throughout the year and other data concepts holding a lot more than just strings. So I'm going to put a comment here and run it, okay? And I'll put another one down here and do it again. And so it should output the strings as well as the length. All right, we got error. Okay, what goes on? Looks like an extra brace down here. We'll try to run it again. Okay, it's waiting for this input line, so I'm just going to type what I typed last night, George. And it outputs here Roger Rabbit, which has been assigned into the string full, and it outputs the length, which is 12. Recall that the index positions are between 0 and 11. Well, we also want to mention here this sort of structure, full dot length, okay? So we've seen things like this before when we said math.pow or math.square root. We've called methods in a particular class. In this case, we don't use the class name like math. We use a object of the string type called full to call its length method. So it's accessing the place in memory where full is located and returning the number of characters in the string. So we're going to pause here a little bit about the significance of strings. Right now there's like probably more strings stored on computers in the world, and it's probably consummate to the idea of grains of sand on a beach. Okay, humans love to collect things, and one of them is string information, and it's all in computers. And so that's why it's devastatingly important for you to understand and to be able to manipulate strings. Well, on the last sense, I'm just going to move this down a little bit and say full dot substring. Okay, full dot substring. Well, obviously we're getting maybe a substring, a certain portion of the full string, Roger Rabbit. And then we go full dot length minus 1. And length is 12 and minus 1 is 11. So we should get the 11th character. Again, it's prompting us for entering in a name. And we get T, which is the 11th character. But what's interesting is there is now a method, substring, to break down the string into subparts. And, well, there's two different substrings. I'm going to just skip this part here and continue on here. I want to take this out, which are comments. Very, very useful. Let's see if I need to add a brace back. Not a parentheses, but a brace. Yeah, I don't know why that is, but as I joke in class, brace yourself. It's the most common error. If you see a little red thing on the line number, you'll notice perhaps it's an open and closed brace. We'll refer to that with the idea that the open brace is here and the closing brace is here, and if you highlight one, then it usually lightly boxes out the closing brace. So it's a little tip in most compilers. Well, let's not waste time. We've talked about the substring method. So let's look at 6. So we know what's at 6, which is R of Roger Rabbit up here. That's in the 6th position. And when I start doing string assignments, what I do is I write them down and put the index numbers after it, try to get a better understanding on a little piece of scrap paper. Especially when you're doing the exams, that's always very useful. So this is a one parameter call to the substring method on the full object, and it will call and return the string from the 6th position until the end. Well, we'll move on. This is a two parameter call to substring. So that's another example what we referred to in the beginning where the substring method is obviously overloaded. One substring method takes one parameter. In the case of line 26, it's the number 6, and the other takes two parameters. And when the two parameter method is called, it calls from the beginning index to the end index minus 1. So what I would expect is rabbi coming out, starting at 6, R, and minusing 1 from 11 would be the 10th character. It would complete the word rabbi. And the next one is another example of 0 and 5, minus 1. The space is in 5, so it'll output indices 0, 1, 2, 3, and 4. Let's run that and show you. Here we go again with George. And so what we have here is rabbit. What we have here is rabbi. And what we have here is Roger. Okay, now that last Roger is outputted by code that I haven't explained yet. All right, so we know about dot length and we know about dot substring. And there's another method on line 31, which is index. And it says, find me the place where the space is. Full dot index of search in the string and return the position. Okay. Well, what I should do is say, I'll probably add this here. I might have and should have done it last night. Let's print out the space, which is going to be the index position where the space is found. Okay, we'll run it again. Again, George. And it's outputting 5 before it outputs the final Roger. The thing to know about the index position is it will return a number less than 0 if it's not found. So we use a little if statement, again something we'll cover in the future. If space is greater than or equal to -1, print out the substring of 0 to the space, which would be the first name, Roger. Now, well, to conclude, really what we have is a preview of a look at string. We'll cover it in more detail in the next module, which is coming up, which, guess what, figures to cover string. And you'll get a lot of experience with string. I promise. It'll be on the AP exam. You'll absolutely have to know it. And this is your first look at it. So hope you have a great week, and I'm looking forward to seeing you again. Reach out if you have any issues.